Hello students, so today we're going to look at using trigonometry with right triangles. What you're going to have on you today, make sure you have your calculator present, a pen or a pencil, and then of course your notes. So we have looked at 3 of the trigonometry ratios that you've learned. You've learned about sine, cosine, and tangent, right? So we have looked at opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. But now there are 3 other trigonometry ratios that you haven't been exposed to yet. These are known as cosecant, secant, and cotangent. Now, what's kind of cool about them is they are the opposites of sine, cosine, and tangent. So sine theta is, or cosecant is the opposite of sine theta. And cosecant, you're going to see that written as CSC. Secant is cosine's opposite, and cotangent is tangent's opposite. I know they're kind of hard to keep in your mind. So a hypotenuse over opposite is the opposite of sine. Notice how it's opposite over hypotenuse for sine, and this one's hypotenuse over opposite, so it's flipped. So cosecant is related to sine, secant is the opposite of cosine, and cotangent is the opposite of tangent. So be careful with that. Try to keep that in your mind as we work through today. Here's the very first example you're going to want to have in your notes. We're going to evaluate the 6 trig functions for the angle theta. This is what this is known as theta. Okay? That's the name for that design. It's a Greek letter. So sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Very first thing I notice, I am missing a side on my triangle. So I need to find that side before I even start my problem. How am I going to find that side of a right triangle when I already have 2 of those sides? I can use the Pythagorean theorem, can't I? So let's set that up. I am going to have x squared plus 15 squared equals 17 squared. Well, I know 15 squared is 225. And 17 squared is 289. Okay? So then I'll subtract 225. I'll get x squared equals 64. Square root both sides. So I get x equals 8. So I know I have a side length of 8 on that side. So now I can find my sine, cosine, tangent, and so on and so forth. So from theta here, I know this is my opposite side, this is going to be my adjacent side, and this is going to be my hypotenuse side. So I recommend finding sine, cosine, and tangent first. So sine, I know that's opposite over hypotenuse, aka 15 over 17. Cosine is adjacent over hypotenuse, which is 8 over 17. And then tangent, I know, will be 15 over 8. With me so far. So I have opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Okay, that's what we've been practicing already. Now, cosecant, secant, and cotangent is just flipped around. So cosecant is the same as sine except flipped. So I'm going to go 17 over 15. Notice how I flipped sine around because it's hypotenuse over opposite. Secant is cosine flipped around, which is 17 over 8. Okay? And then cotangent is tangent flipped around, so that would be 8 over 15. Now, let's try this kind of example. Let theta be an acute angle in a right triangle. What are the values of the other 5 trig ratios in the triangle? I am given that cosine theta is 7 over 10. Very first thing I'm going to do, I am going to draw myself triangle. Okay? And I'm going to label this as theta. Alright, So now cosine would be adjacent over hypotenuse, right? You're with me? So this would be adjacent in the hypotenuse. So my adjacent side is 7, and my hypotenuse is 10. That's technically what it's telling me, correct? So now I need to find my opposite side. So let's find the opposite side here. I'm going to have 7 squared plus x squared, equals 10 squared. So 49 plus x squared equals 10 squared. 10 squared, that's 100. Not thinking today. 49 here and 100 there. Okay, I'm going to subtract 49. So I will get 100 minus 49. I'll get 51. Square root both sides. That's just going to stay the square root of 51. That doesn't break down, unfortunately. So I can now find my other 5 ones, because I already know my cosine, right? So my sine is going to be the square root of 51 over 10. I'm going to leave it like that. Cosine I already have, but I can just put it in my list so I don't forget about it. 7 over 10. My tangent theta is going to be opposite over adjacent. So square root of 51 over 7. Now, my cosecant, CSC, is going to be my sine theta, right? Flipped. So 10 over the square root of 51. Now, I can't have that. So I'm going to multiply by square root of 51 over the square root of 51, aka 1, right? So then I'm going to get 10 square roots of 51 over just 51. Okay? And so I'm rationalizing that denominator. I don't want a square root on the bottom. That is a big no-no in the math world. Let's do the same thing. Cosecant, so that's going to be my secant. That's going to be 10 over 7. Nice easy one, right? And then cotangent. It's going to be 7 over the square root of 51, which is aka, if I multiply by the square root of 51 over the square root of 51, I'm going to get 7 square roots of 51 over 51. Those are all 5 of my answers for that particular problem. Now, how about a triangle with 30, 60, 90, and 45, 45, 90? So these are very special. Remember, your small leg, your short leg is 1, so my hypotenuse is double, and then my long leg is the square root of 3 times our short leg. So now, what about the sine of 60 degrees? So I'm going to find the 60 degrees. Sine of 60 would be opposite over hypotenuse. So that's going to be the square root of 3 over 2. Okay. Cotangent of 30, that is, okay, so tangent would be opposite over adjacent, right? So my cotangent is going to be my adjacent over my opposite. So my adjacent of 30 is the square root of 3 over my opposite, which is 1. Try to keep those in your mind. Cotangent, those are very hard to think off the top of your head. But think of who they're related to, and then go back and flip it around. What about the secant of 45? So that would be the cosine of 45 flipped. Cosine is adjacent over hypotenuse. So this would be hypotenuse over adjacent of 45. So my hypotenuse over my adjacent. Square root of 2 over 1. Solving a right triangle, aka find everything that we can find. So I need to find all the angles. I need to find all the sides. So I am given that the angle of B, his measure is 25 degrees. So I'm going to put that in the little triangle right here. And then C is 10 degrees. So C is 10. Notice how side A is opposite of A and side B is opposite of B. Okay, notice that. Now, what I need to do is I need to find my other angle. That's going to come in handy. I know that all 3 of these angles together add up to 180, right? Right now, I have 90 plus 25. I have 115 of that 180. So if I do 180 minus 115, I'll get A. So I'm going to do angle A equals 180 minus 25 minus 90, aka 65 degrees. So I get angle A is 65 degrees. I found all my angles. That's half the battle. Now, let's find angle A, or side A and side B. So, I'm going to use some trigonometry, ladies and gentlemen. So, I'm going to use 25 degrees. Using 25 degrees, this would be my opposite. This would be my hypotenuse, right? So, I can use sine of 25 equals B over 10. So to solve for B, I would multiply by 10 on both sides. So I'll get B equals 10 times the sine of 25, 4.23 if I round to the nearest hundredth place. So that would be one of my answers. Now I need to find A. You could use adjacent over hypotenuse, which would be cosine, but since I found that 65-degree angle, I'm going to use sine again. Sine of 65 equals A over 10. Multiplying by 10 again to get rid of it out of the denominator, I'm going to get A equals 10 times the sine of 65, 9.06 if I round again to 2 decimal places. So I have solved this triangle. I have found everything that I possibly could find about that triangle.
And that's the end of this video. See you later, Sabers.